All right, let's take a look at position, distance, velocity, and acceleration from a graph. And we'll probably put speed in there too. So let's first look at this being the velocity graph, and this is in feet per second, whereas this is in time in seconds. So the first question says, when is the particle moving at a constant speed? Well, constant speed just means that the velocity function is constant. So in this case, it's just from 0 to 1. And you can include endpoints or not if you'd prefer. I typically do not because I find it easier to err on the side of not including them unless we're forced to include them. So then when is the particle moving to the right? Well, the particle moves to the right anytime the velocity is above the x-axis. So in this case, we will have to include the endpoint of time equals 0 because velocity is clearly positive here. You may or may not include time equals 2, but I do not typically include the endpoints unless I'm forced to. When is the particle moving to the left? That is when velocity is below the x-axis. So that's going to be on the interval from 2 to 5. All right, when is the particle speeding up? Remember that this is where acceleration and velocity are the same sign. So speeding up, let's see, here I have velocity is positive but decreasing, so acceleration is negative. That's opposite sign. Here I have velocity negative and decreasing, so acceleration is negative. That's same sign. So on the interval from 2 to 3, the particle is speeding up. Let's look at one last interval. Here velocity is negative, but increasing, so acceleration is positive. So we have opposite signs here. Notice that I ignored this first section because velocity is positive, but acceleration is 0 because velocity is constant. So when is the particle slowing down? Well, that's the two intervals on which velocity and acceleration had different signs. So that's on 1 to 2 and on 3 to 5. Let me write that in here, 1 to 2, union 3 to 5. And let's keep in mind that that is where acceleration and velocity have opposite signs. Okay, when is the particle's velocity increasing? Well, then I just need where the velocity function is headed upward. The y values are increasing. So that is on the interval from 3 to 5. And then where is velocity decreasing? That's going to be on the interval from 1 to 3. And some people disregard this point here because there's a cusp. And that means acceleration is undefined because of this corner point. It's not really a cusp, it's a sharp corner. So you can say 1 to 2, union 2 to 3. But I don't think I've ever seen on the AP exam where they put in a question like this where you would be penalized if you included the 2 or not. So I don't want you to stress about that, but I'm just pointing it out that technically speaking, you would not include the 2 here because acceleration is not defined at this sharp corner on the velocity curve. So the next question says, are 6 and 7, where velocity is increasing and decreasing, the same as where the particle is speeding up or slowing down? And the answers are not the same because velocity and speed are not the same thing. So velocity increasing and speed increasing are two different concepts. So velocity does not equal speed. And that's why these answers are different. So how fast is the particle moving at 4 seconds and in what direction? When it asks you fast, it means speed, not velocity. It's not including direction in it. Notice that they put in what direction as a separate question. So what they want you to say at 4 seconds is that the particle is moving 5 feet per second. So they're taking the negative 5 of the velocity curve, converting it to a positive for speed, and then putting the direction in words. We're going to say to the left because a negative direction is to the left. And of course, that's from the assumption up here that the positive direction is to the right. Next question, what is the particle's velocity at time equals 4 seconds? Well, velocity includes direction, so that will be negative 5 feet per second. And the last question here is, not the last question. Next question here is, when does the particle change direction? Well, that's going to be at time equals 2 because that is where the velocity goes from positive to negative. So we have time equals 2 seconds. Now, how far does the particle move during the first second in which way? So this is a little bit of foreshadowing into the second branch of calculus that we'll study, which is the integral. But for now, let's just take a look at the first second. The particle is moving at 5 feet per second on the interval 0 to 1 seconds. So if I multiply 5 feet per second times 1 second times 1 second, I'm going to get out 5 feet. And because velocity was positive, the particle is moving to the right, 5 feet to the right. So the next question is, how far to the right does the particle go and when does it get there? And yes, there's a typo in here. Sorry about putting in to the right twice. So, well, if you take a look at this 5 feet to the right that the particle moved in the first second, you notice that I actually kind of drew in this area. Well, the area of this block is equal to that 5 feet, 1 second times 5 feet per second. Similarly, we can find the area of this triangle here, and the area of a triangle, of course, is 1/2 times base times height. So this area will be 1/2 times a base of 1 second times a height of 5 feet per second. So that's going to give us 2.5 feet. So if I add this 2.5 feet to this 5 feet, that means that the particle moved 7.5 feet to the right, and it got there at time equals 2 seconds. And of course, that's where it changes direction. So that's when it's farthest to the right. The total distance traveled by the particle. Well, we now know that right here, the particle went 7.5 feet to the right. So now we just need to find out how far the particle went to the left. So we can find the area of this triangle as 1/2 times the base of 3 times this height of 10. It's actually -10, but since I'm doing total distance traveled, I want to count distance moved to the left as a positive. So I'm just going to use +10. So this is 15 feet to the left. So that means that the particle went 7.5 feet right and 15 feet left. And so 22.5 feet overall.